Okay, I've had a question on problem 52 in section 5.2. Let me double check to make sure that's the correct question here. Yeah, number 52 in section 5.2. And so to get to this here, we're given the function the inverse tangent of x, and we're supposed to determine intervals of concavity. Now, before we tackle this problem, we should maybe talk about what the domain of the inverse tangent function is. And it turns out the domain of this is all real numbers. And so we need to, of course, get to the second derivative. So the first derivative should be straightforward to us. All we have to do is remember what the derivative of the inverse tangent is, which is 1 over x squared plus 1, or, 1 over 1 plus x squared. You can write it either way. Alright, so then I need a second derivative. But before I do the second derivative, I'm going to rewrite this as x squared plus 1 to the negative 1 power. Because I have to use a chain rule to take the second derivative. So what would I get here? I'd get negative 1 times x squared plus 1 to the negative 2 power times the derivative of x squared plus 1 because of the chain rule. So this would be equal to negative 1 times x squared plus 1 to the negative 2 power times 2x. And then just cleaning this up a little bit, because we're going to need to determine when this is 0. Just a second, my pen for some reason is not working. Oh, there we go. F double prime at x would be negative 2x over x squared plus 1 quantity squared. Now that I have my second derivative here, I just need to find when that's equal to 0 or undefined. Now this is never undefined. How do I know it's never undefined? Well, for it to be undefined, we would have to have x squared plus 1 equals 0. And that's never going to be satisfied for any real number. If you use an imaginary number like I, you can get it solved, but we don't use those in this course. So it's never equal, it's never undefined. So I just have to determine when this is equal to 0. So really, I just have to determine when the numerator is equal to 0. Which, of course, that just gives me x equals 0. So then I'll go ahead and draw a number line here, much longer than I really needed it to be, and I'll put 0 there. And then, because we're looking for concavity, of course, I have to test my second derivative, which I'm going to write down again here just so I have it close at hand. Negative 2x over x squared plus 1 quantity squared. And now we just have to test some numbers here. So, for instance, I might just go ahead and test x equals negative 1. And if we do that, we get f double prime at negative 1 is equal to negative 2 times negative 1 over negative 1 squared plus 1 squared, which would be 2 over 4. And I mean, I could simplify that down if I wanted to, but the key thing here is that's positive, so that means that we are concave up for that interval. And then we do the same thing here, and I would probably just maybe test x equals 1. So f double prime at 1 is equal to negative 2. Now I was about to write negative again. Negative 2 times 1 over 1 squared plus 1 quantity squared, which would be negative 2 over 4. And again, the key thing here is the fact that I have a negative. So that means I am concave down. So now I can just write the answer down for this problem. So we are concave up from negative infinity to 0, and we are concave down from 0 to infinity.